Welcome to a lesson with Dr. Powell. Let's look at the idea of limits by sandwiching. For instance, suppose that we had a function that looks something like this. 1 plus the cosine of x all over x, say, and then maybe we had something like 2 here, and we're taking a limit as x approaches infinity. All right. Now, for one, let's think about this. This, as x approaches infinity, cosine, how does it behave? I mean, it doesn't have a limit. The limit doesn't even exist. However, it is bounded. We know it's between -1 and 1. Let's use that bounding idea, that it's bounded, to produce an inequality. This right here is less than or equal to 1 plus 1 over x all over 2. That's because the biggest that cosine can be is 1. So, and this is all positive, especially as x is heading out to infinity. So this over this is clearly less than that. And it's likewise just this piece of the numerator smaller than that piece makes the whole numerator smaller, hence the whole fraction smaller. Now, likewise, we could also say the following. We could say 1 minus 1 over x, and this would hold. Notice how we sandwiched our expression right here that represents our function that we're taking a limit of between two other expressions, which could represent functions that we can take limits of. So then if we take the limit of this one as x goes to infinity, this part goes to 0. So we're left with 1/2 on this side. And then over here, we're left with 1/2 as we take limits. Now, the idea is, since this is between these all the time, and this limits to 1/2, and this limits to 1/2, and this has to be between 1/2 and 1/2, well, that means that this also limits to 1/2 as well. So that is what we call limit by sandwiching. If we can take an expression and find an inequality on either side of it, and both of those parts go to the same number, then the middle part will also go to that same number. Thanks for watching.